Hello everyone. Today we're going to be making the sheet metal box for the ME250 class.
Alrighty, so whenever I build anything, I like to ask myself, what am I trying to accomplish? And in this case, what I'm trying to accomplish is this sheet metal box right here, which is going to be used as a base for the hole punch that you'll make later on. This base just sits, the hole punch just sits on this, and it catches the paper as you go to punch holes. So that's all this is. Now, when we go to build this thing, what we need is actually a drawing. Okay, so here's our drawing right here, and a couple of key things to note on this drawing. One is that there will be some inspectable dimensions, and those are circled pretty clearly. So the two that are inspectable are going to be right here, and that's the distance between these tabs. So we're talking about the distance right here between the tabs. And the second inspectable dimension is going to be the flatness of this surface right here. So in this case, we're talking about how much does this tab differ from this tab in terms of height. So we want that to be very, very flat. So those are the inspectable dimensions. The other thing that needs to be noted is that you'll end up stamping your initials in the approximate location. So that's in the center of the box. It literally just is right here in the center of the box. The third thing that's on here is to deburr all the sharp edges. Now in this case, what we're talking about is that nothing on here can cut me. All these things have been filed and deburred so that there's no burrs on them, and they're not going to be able to cut me. So the next step we're going to do is actually take a piece of sheet metal and put some layout dye on it so that we can cut this thing to the correct length. Okay, so we've got our piece of stainless steel sheet metal, and we've went ahead and painted some layout dye on it, and now we're ready to scribe the line in here to tell us how long this thing needs to be cut. Now in this case, what I'm referring to is this dimension right here, the 3.45 plus 0.015 minus 000, which means that this thing cannot be any smaller than 3.45, but it can be a tad larger. So in order to actually scribe this line in here, what I'm going to use is my pair of calipers. And I'm going to move this pair of calipers to 3.45, as close to as I can get. And once it's at 3.45, then what I'm going to do is actually use the tip to scribe in that line. So let me show you how to do that now. Now when you're doing this, you need to be really careful that you don't put too much pressure and bend this tip of this caliper here. And if you notice, I also put this little lock nut on here so this can't move. So now what we do is we take this left side of the calipers and we bring that up against the left side of the raw material here, and then we just press and scribe this line in here. And for me, it looks really clear, and hopefully in the video you can see that as clear as well. So now we have this line scribed in here, and we're ready to take this over to the sheet metal shear to actually cut this thing.
Alrighty folks, so here's our sheet metal shear, and this is what we're going to be using to actually cut this piece of sheet metal. So we're just going to put that on here, and we're going to go ahead and cut this thing.
Alright, so now that we have the line scribed, our scribe line, in our piece of sheet metal, we're ready to shear this thing and cut it. So what we're going to do is we're going to set it on this plate, and with a lot of pressure here down towards the bottom of the video here, we're actually going to be putting a lot of pressure on this plate to hold this sheet metal in place. So we're going to literally be pressing here as we do this. We're going to be looking between this yellow clamp plate and the side of this piece right here to line it up. And what we want to do is make sure that this thing cuts in the right location. So I'm going to line up that scribe line with the side of the plate, the end of this plate here. So I'll do that now. Okay, so I have this thing lined up. Now I'll go ahead and step on this thing and cut it. And there we have it. Here's our finished piece of cut sheet metal. Okay, so now that we've got this thing cut, the next thing we're going to want to do is actually inspect this thing to make sure it's the right length, because there's no point in us continuing if it's not to the right length. So if you remember, it's 3.45 is what we're shooting for, and it can't be any smaller than that, but it can be slightly larger than that. So in this case, what I cut is 3.45 right on the nose, so I'm ready to go ahead and get started with the rest of the process. Our next step in this process is to use semi-precision layout on this piece of stainless steel to actually tell us where we need to make these bends and where we need to punch these holes and notch out these corners. So in order to do that, what I'm going to do is set my calipers to this distance right here, which is 0.48. And I'm going to scribe in a line away from each side at 0.48. Once I get it to 0.48, I'll just lock this into place so it can't move around. And now I'll scribe these lines around each of the four sides. There's 1, 2, 3, and 4. So now that I've got these lines scribed, I'm going to take one of these prick punches, which is a small punch, and I'm going to punch in a little divot into where these lines intercept. And what this is going to do is going to give me a place to ensure that my hole punch takes out these punches at the right location. So we'll take this small punch and we go ahead and get started. And I use this small punch because it has a thin angle here, and that allows me to more easily see where exactly I'm making that punch so that I get it the right place. Then I take a larger, more stout punch and I make that hole even bigger. Now I'm able to take this piece of stainless steel over to the hole punch and punch out these 4 holes.
Alrighty, so we're standing here with our sheet metal hole punch, and this thing punches holes in sheet metal. I went ahead and installed the 0.125 inch punch into this. If you need help doing that, please come see a shop employee and we'll help you do that. And all we're going to simply do is slide this piece of sheet metal in here, and at the bottom of this punch there's a tip, a sharp tip. And what we're going to do is we're going to align that sharp tip up into this hole that we already punched with the center punch to make sure it's in the right location. So I go ahead and slide this in here and I lower this down a little bit and I start wiggling this thing around until this piece of sheet metal slides into that tip of the punch. And now that it's in the correct location, I just pull this thing down and take that punch right out, pull it on up, and now we've created our hole punch. I'll repeat this same process for the other 3 holes. Alrighty, so now that we have the holes punched in here, we're going to go ahead and use this notcher to cut the square tabs out. And so we're going to slide this in here right here. And what we want to make sure we do is we line up this line that we scribed right here with this side of the notcher, and this line that we scribed right here with this side of the notcher. We really want to make sure that we cut the right place, because if we don't, we won't be able to bend it in the right place. So we'll take our time in doing this. So I'll go ahead and bring this, lower this down, and now that it's lowered, I can get a better idea on exactly where it's sitting. Once I get it to the right place, it's all lined up, then I'll go ahead and take this cut right out. So now that's cut, I'll repeat this process for the other 3 sides. We're now going to use the box and pan brake to bend the 4 sides together so it makes a box.
We're going to begin by bending the long side first. So what we're going to do is we're going to go ahead and slide this piece of sheet metal around until we get it lined up. And what we're trying to line up here is this silver line that we can see due to the scribe line and the edge of this tooth. So we want those things to be perfectly aligned. And one thing you'll notice is that when you go to lock this thing into place, it actually shifts forward. So you want to make sure that your final place is indeed the place that you want to bend it at. So take into account the fact that this thing shifts forward in your lining. So now that it's locked into place, we'll simply just bend this thing on up. We'll go ahead and repeat that process for the other side. And we want to pay particularly close attention to where we're bending this thing to ensure that we're bending it at the right spot. So now we're ready to bend the short sides. All right, so now that we have the long sides bent, we'll go ahead and bend these 2 short sides. We'll use this narrow tooth to do it. Of course, the width of our tooth has to be less than the width of this opening here. We'll repeat the same process, paying particularly close attention to the fact that this thing needs to be aligned properly before we bend it, and that our final locked location is actually what we care about. So now that I got it locked into place, I'll bend this thing forward, and I'm just going to bend it all the way until it stops. There it is, and I'll repeat that process for the other side. Okay, our sheet metal box is now all bent up. We're ready to take it over to the sandblaster and blast it clean.
So here's our sandblaster. Let's take a look inside.
Inside this sandblaster is a nozzle, and this is actually what you use to blast your part. So in this case, we'll put this in a bucket and squeeze this trigger to actually allow the sand to hit it. This sits inside here. In order to load the part into the sandblaster, you open up this hatch and load it right in. Alright, so we're ready to begin sandblasting. We go ahead and turn it on, stick our hands inside the glove, and use that nozzle to direct the sand where we want it to go. Alright, so we finished sandblasting. We'll go ahead and take a look. And here's our finished box, all sandblasted, ready to take another look and make sure that it's all in spec and it's made to the right size. Alrighty, so our next step is to punch our initials into this sheet metal box. If we remember, we're supposed to punch our initials right here in the center. The drawing tells us to do that. So let's go ahead and do that now. We want to make sure that we line it up properly. So my first initial is an S. Let's get that in there. I got the X, the S, my next initial is an H. Let's get the H in there. Okay, I got the H punched. Now my initials are done. Okay, so now that my box is all built, I need to inspect it. And the first thing that I'm going to inspect is going to be the dimensions that are circled. Okay, so the first one is going to be the distance between these bent tabs. So what I'm going to do is I'm going to get a feeler gauge. Now this feeler gauge is made at 0.038 wide. So it's going to tell me whether these gaps are too big. If you can fit this feeler gauge into these gaps, I know that I'm not within tolerance. So I'll go ahead and I'll inspect all of these gaps to make sure I cannot fit this feeler gauge in there. And indeed, it does pass inspection. The next thing I'm going to inspect is the flatness. Of course, I want all of these tabs to be the same height or to be flat on that surface. And in order to inspect that, I'm going to take this and I'm going to place it onto a surface plate. This is a marble surface plate for inspection. And I'm going to try and slide this feeler gauge in between these gaps to see if it fits. And if it fits into the gaps, then I know that it's not within specification. So in this case, all my gaps are good. They're small enough that it passes inspection. The next thing I'm going to inspect is to make sure this thing's square, because it needs to be square. So I'll get my combination square, and I'll just inspect all of these edges here. And indeed, all four corners are square. So this box now passes inspection, and it's good to go. Of course, we will require you to know how to inspect all of your own parts. This class isn't just about building this stuff, it's also about knowing how to inspect it. So this is something you'll need to learn. Oftentimes when we build something, it's not within tolerance. And so what we do is we do a process called rework to make sure that the part falls within tolerance. One of the most common problems with this sheet metal box is that the height of these tabs are not all the same, making the flatness of the box the tolerance unmet. So for example, if I take this box and I was able to slide this feeler gauge into this side, that would indicate that this tab here is too tall. In order to shrink this tab down so that this whole surface, the top surface of this is flat, I can take this on over to a bench vise like this one here and delicately clamp this in here. And I say delicately because you don't want to deform this box. So we delicately clamp this in here, and then we take our flat file and we just file these tabs down so that they're the right height in relative to the other tabs. Now we can do this rework process and still have this part be within specification, within tolerance, because if you see the tolerance of the height, it's quite large. So here's our dimension of the height, it's 0.5, and if we go to our tolerances down here, that indicates that the tolerance for that 0.5 dimension is 0.03 or 30 thou, which means the height of this box can vary 30 thou. So we got a lot of room to play with there, and so if we file this thing down a few thou, it won't make the height of this go out of tolerance. So that's something that's good. The other rework process you may need to do cannot really be done until you build your hole punch. And that rework process is to ensure that these tabs are bent in enough. Now, if you notice, these tabs are actually bent in past these ones here. Okay, so they're actually literally bent in like this. And that makes this sheet metal box clamp onto the base of our hole punch. So here it is, it's clamped on there, and it holds on its own. Now, if this didn't clamp on there properly, that means that these tabs aren't bent in enough. And so we can bend them in a little bit further with a pair of pliers. So you just take your pair of pliers and you ever so delicately bend this tab in a little bit further, and then you check with your base to see if you've got it done enough, right? So again, of course, you won't be able to do this particular rework process until you have your hole punch made. But that's how you do it once you do build your hole punch. Now this thing is sitting on here as it should. It's not falling off. It's now complete and it's functioning properly. We are now done with our sheet metal box.